Question number 32 says integrate 1 upon 1 plus cot x. This is a pretty interesting one. And observe carefully how this kind of question will be handled, right? So I is equal to integral of 1 upon 1 plus cot x. 1 plus cot x, if you take a look at this carefully, in the denominator it is creating a lot of problems, but even if you try to bring it in the numerator, it will not be possible, right? The derivative, there's nothing in the numerator, right? So let's create something in the numerator. And one of the ideas could be to multiply by 1 minus cot x, 1 plus cot x, 1, no, it will not help. But then cot x can be converted into cos and sine, and what I'll get in the denominator is cot x is cos x upon sine x plus 1. So this becomes cos x plus sine x, and this becomes sine x, right? Dx. That's what you get. Multiplying and divide by sine x, that's what you get. Okay. Multiplying numerator and denominator by sine x is what you will get. Now, after reaching this stage, I remember something from the past few questions that you remember that question which had 6 sin x plus 4 cos x and 2 sin x plus 2 cos x plus 3 sin x in the numerator. So, sin cos can be converted in terms of sin cos, right? The derivative can be written in terms of sin cos. That's something which is useful, right? So, derivative of cos x plus sin x will be equal to this cos x, the derivative will be minus sin x, the sin x, the derivative will be cos x, right? That's what you'll have. So, you'll have to create some cos x over there. Okay, and how do we do that? So let's do one thing. Instead of a single sin x, let's create 2 sin x. Okay, half is okay. What I've done is I have created 2 sin x so that I can write it as sin x plus cos x once and plus sin x minus cos x again for creating that extra sin x. Mind you, this converts to its derivative, but this can also be converted, right? I can write cos x plus sin x also in the numerator because that will simplify, right, and that's the beauty of this step. This is very, very important, this particular step, tuck and tuck. These two steps are very, very important, and if you observe these carefully, 1 by 2 integral, this becomes sin x plus cos x, cos sin x plus cos x, this is 1 plus this becomes, okay, the derivative of cos x is minus sin x, so we can take out a minus common from here. We can take out a minus common from here and this becomes this, right? In the denominator you will have sin x plus cos x, okay. In the numerator you can take out a minus common, this becomes cos x minus sin x. Now it is in the exact form in which you want it to be. The derivative of sin x is cos x is minus sin x, the derivative of this denominator is present in this numerator, right? So for this second term, this first term, the integral is very simple. For the second term, we can take sin x plus cos x as t. And this becomes, this times dx becomes dt. dt upon t, integral is log of mod t. I can write that directly now, yes. We've solved so many questions. So therefore, I becomes equal to half is okay. In the bracket, you have x minus, once again, this is dt upon t, right? So that becomes log of modulus t, which is sin x plus cos x modulus plus constant term, right? So this is x by 2 minus 1 by 2 log modulus sin x plus cos x plus constant. That is my required answer for this question over here. Pretty interesting, right? This is a very important step.